Today, we will discuss the basics of lasers and laser light, different hazard classifications, ways that the beam can injure you, and how to protect yourself. Light is an electromagnetic wave, measured by the distance between two peaks on the wave, called a wavelength. Different wavelengths in the visible spectrum appear as different colors. Stimulated emission is when an excited atom is struck by a photon in the laser beam, producing additional photons with the same direction, wavelength, and phase. The combination of these three properties makes laser light capable of focusing 100 times better than ordinary light. All lasers have the same basic design. The active medium contains atoms excited by the excitation mechanism. Photons produced in the active medium are collected in the resonating cavity until they're released by the output coupler. Lasers are classified from 1 to 4 according to the level of radiation that you're exposed to during normal operation. 1 being the least hazardous and 4 being the most hazardous. Class 1 normally refers to a system with interlocks that does not allow the user access to the beam during normal operation. However, during maintenance, classification may change if the interlocks are disabled. Class 2 applies to visible lasers only, with a continuous wave maximum power of 1 milliwatt. Staring into the beam for several seconds is an eye hazard, but your eye is protected by the aversion response, meaning you can blink your eyes or turn your head fast enough to avoid damage. Class 3R also only applies to visible lasers, with a continuous wave maximum power of 5 milliwatts. However, for Class 3R lasers, the aversion response is not adequate. Class 3B applies to visible or invisible lasers, with a continuous wave maximum power of 500 milliwatts. Direct exposure to these beams are an eye hazard. Class 4 applies to visible or invisible lasers with a continuous wave power of greater than 500 milliwatts. They are an eye and skin hazard when exposed to the direct or scattered beam, and they can even be a fire hazard. When you purchase a laser, you should find these two labels. The triangle will tell you that it's a laser, and the rectangle will tell you its classification, wavelength, and maximum power. A specific sign should be posted at the entrance to any lab with an operating laser. Caution is used for Class 2 or 3R lasers, and danger is used for Class 3B or 4. The sign should include any potential hazards, the type of laser, its wavelength, maximum power, and classification. Beam exposure is not the only hazard in a laser lab. Depending on your setup, you can have electrical hazards from high voltage power supplies. Smoke and fumes can be generated by the laser, as well as mechanical hazards, process radiation, and chemical hazards if you're using dye lasers. Lasers operate in the ultraviolet, visible, near-infrared, and far-infrared regions of the electromagnetic spectrum. The region that you're exposed to determines how it may affect your eyes. Lasers in the UV range can cause damage to your cornea. Lasers in the far-infrared range can cause damage to your lens. Lasers in the visible and near-infrared range can both cause irreversible damage to your retina. However, the near-infrared range is also invisible, making this the most hazardous region to work with. There are 3 types of laser eye exposures: intrabeam viewing, which is looking directly into a laser; specular reflection off of reflective objects such as mirrors or jewelry; and diffuse reflection off of rough surfaces such as a wall. Diffuse reflections are only an issue for Class 4 lasers. The most common causes of laser accidents are inadequate training of personnel, including lab-specific training, inadequate alignment procedures, not blocking stray beams or reflections, not wearing appropriate eye protection, or following standard operating procedures. Now let's move to the lab where Dr. Tim No will review correct alignment procedures. Over 60% of all accidents involving a laser occur during the alignment process. That makes laser alignment the most hazardous activity performed in a laser lab. Therefore, today we are going to review some basic alignment procedures. But first, some ground rules.
When approaching a laser table, it's often a good idea to look for various unnecessary reflective surfaces that may send the beam towards your eye. For instance, here's a mirror. So remove these items and set them aside. It's also a good idea to look for reflective surfaces that you may be wearing, for instance, a ring or a watch. If you have a watch on, before turning on a laser, remove it and set it aside as well. Next, consider the hazards of the lasers themselves. For instance, here, we're using a helium neon laser as a dummy tracer beam. This is a class 3R laser, so it's safe to use without laser goggles. On the other hand, here we have a laser diode. Now this wavelength is at the edge of the visible range, so you can't see it very well, but this does have more power. With a class 3B or 4 laser, you need to be sure to wear appropriate laser safety goggles. But for now, we're going to do basic alignment with the Heine beam. So what I like to do to begin with is to block the output of the beam right at the beginning. Then with an index card, trace the path and block with each successive optic as you align the beam down the table. So now we need to put on the goggles and repeat the process with a higher powered laser. Now because this is an invisible laser, we can't use an index card to trace the beam. Instead, we need to use an IR card. Whoops. This leads me to another point. When bending over, your eyes might cross the level of the laser beam. So it's a good idea to turn your back to the table and close your eyes on the way down and on the way up. Now, when you're done using the IR card for aligning the beam, it's also a good idea to use an IR viewer to look around the room for any stray reflections or light that has left the table. You can also use a beam enclosure to keep the laser beam from leaving the table. Now for some special situations. When aligning a Q-switched laser, operate in CW mode. Also, remember to be extremely careful when using an amplified Ty-Safra laser or any class 4 laser, as scattered light can still cause significant eye damage.
There are two terms that we use when talking about laser exposure. First is the maximum permissible exposure, which is the level of laser radiation that you can be exposed to without damage. Next is the nominal hazard zone, which is the physical space where you might be exposed to levels of laser radiation above the maximum permissible exposure. There are three types of control measures that we use to protect ourselves from exposure. Engineering controls are physical barriers that we put between ourselves and a laser. Administrative controls are things such as policies, and procedural controls such as standard operating procedures. The most common types of engineering controls that you'll see in a laser lab are protective barriers, curbs on your optical table, or enclosures. Laser in use signs at the entrance of every laser lab are an example of a procedural control. However, they're only effective if you turn them on when the laser is on and turn them off when the laser is off. Now let's go over some important PPE. Correct eyewear is critical in hazardous situations. Only eyewear in the correct wavelength range and optical density will protect you from your laser. If you have any questions regarding selection, please call Environmental Health and Safety. It's also important to wear a lab coat when using class 4 or UV lasers, because these have a potential to burn your skin. Remember that you are responsible for the hazards associated with your laser. Understand those hazards and evaluate their control every time you walk up to your table. Remember to never operate lasers outside of a laser lab, and remove any reflective objects such as mirrors or jewelry. Ensure that the plane of your laser is well above or below eye level. Never view class 3R or higher power lasers with optical instruments, and always wear appropriate protective eyewear when working with class 4 invisible lasers. In the event of an emergency, turn off all of your lasers and contact the Rice University Police Department. After the incident is over, fill out an accident injury report form, and if applicable, an employer's first report of injury or illness. For any general questions, contact DHS or refer to the Laser Safety Manual at safety.rice.edu.